All right, the energy packet problem A. Here we go. So I have an object. It is being stretched by a constant force, and I want to know the position when it stops. So here we go. We have F times X, and the effect of this work is that the block acquires spring potential energy. So we have Fx equals 1/2 kx squared. We can actually cancel our x, and so we'll get x equals 2F over k. When we actually calculate that out, that's going to be 2 times 3 newtons divided by, sorry, that should be k, over 50. And that's going to give me 0.06 meters. Now, for B. Actually, before I get to B, I don't know, I seem to consistently make this mistake. This is 0.12 meters. I apologize for that. Now for part B, we want to know the work that has been done on the block by this applied force. So work is F times X. And if I were doing this just with variables, that would be F times 2F over K, which is 2F squared over K. When we actually work this out, that's going to be 3 times 0.12, which is going to be 0.36 joules. For part C, we want to know the work that's been done by the block on the spring force. Well, let's be clear, the spring force is trying to slow the block down. So it does negative work. So to this end, it actually does negative 0.36 joules of work. Now for part D, we want to know the block's position when its kinetic energy is at a maximum. So we have this work being done on the block. And what does this work do? Well, the first thing it does is that it gives the block kinetic energy, but it also gives this block stored potential energy. So what we're going to do is let's get a kinetic energy function, which is going to be f dot x minus 1/2 kx squared. And now what we're going to do is we're going to maximize this function. So we'll take dke dx and set it equal to 0. So when we do that, that's going to give us f minus 2kx. We'll set that equal to 0. And x is going to equal f over 2k. Let's plug in our numbers and see how that works out. So x is going to equal 3 newtons divided by, and you know what? I did this, this is 1/2 kx squared, so that's 2 times 1/2, so that should just be f minus kx, so this will be f over k, which will be 3 over 50. That's going to give me 0.06 meters. Now for part E, let's go ahead and get the kinetic energy. That's going to be f dot x minus 1/2 kx squared. We'll put in our numbers. That'll be 3 times 0.06 minus 1/2 times 50 times 0.06 quantity squared. When we work all this out, we should end up getting here something along the lines of 0.09 joules. All right, so that is it for problem number 1 on the energy